All right, we're going to call this lesson 2.8. Got cut out by the hole punch there. All right, so determine whether or not these relations are linear. So this is the last part of section 5.6, and I'll give you some work, assign some work for you to do. And then the next day, watch out for the last section, right? So we're going to determine whether or not these are linear. Justify your answer. If linear, determine the rate of change. Okay, so we can only do the rate of change if it's actually indeed linear. Okay. All right, a new car is purchased for 24,000 every year. The value of the car decreases. Sorry, this is supposed to be a period here. Yeah. Okay. Every year, the value of the car decreases by 15%. The value is related to time. So if something decreases by 15% every year, that means that 85% of the value is still there. So what we're going to do here is multiply by 0.85. That's what we're going to do to get from one to the other, from 1 year to the other. Okay? We're going to multiply by 0.85 because the value of the car is 85% of the previous year's value. So if something decreases by 15%, that means that 85% is remaining. And so because of this, we're going to multiply every year to find the value. We're just going to multiply by 0.85. That saves us time. So we have time in years. Okay, the value is related to time. And this is the value. And that's in dollars. Okay, so we've got when you buy it after 1 year, 2 years, 3 years, so forth. And the value when you buy it, it's 24,000. Okay. Then how would you find the next year? Well, you go 24,000 times 0.85, you get 20,400. Then you multiply that by 0.85 again to get what's the value is the next year, and that's 17,340. Then times 0.85 again to get 14,739. Okay. Now, some of you might say, couldn't I just find 24,000, find what 15% is, and then subtract that from 24,000 to get 20,400? Yes. And then couldn't I find 15% of that again and just add it to what the value is after the first year and get the next year? Yes, you could. That's just a longer way of doing the exact same thing. Okay. Now, let's see if this is linear. So if we're checking for it being linear, we have to see that something is increasing or decreasing by a constant rate. And it's going up by +1. Okay. Over here, what's happening here? Well, obviously it's a decrease. Okay. So you'd have to go this minus that, right? 20,400 minus the previous. It's always like that when a table of value occurs. You're decreasing by 3,600. Then the next decrease is 17,340 minus 20,400. That is 3,060 minus, right? And so forth. So actually you could stop there and just say, hey, it's not linear because, right, as soon as one of them is different, the whole thing is off. Right? As soon as one of them is different than the one before, it's not constant. This relation is not linear the second column, the dependent variable is not decreasing by a constant amount. And that would be it. Okay, so no rate of change can be figured out there. Okay. B, for a service call, electrician charges as flat rate, so just for coming out, $75 right away, plus $50 for each hour he works. The total cost for this service is related to time. So now time, right, you always want time as your independent, and cost as your, in this case, is your dependent. Okay, so time 0, 1, 2, 3. By the way, right, it's the independent variable, so you can then just decide, hey, I'm just going to go up by 1 here, starting at 0, right? So even though the electrician shows up, has worked 0 hours, you still charge 75 bucks, right? After 1 hour, you would owe the electrician the 75 plus another 50, which is $125. And so for every hour after that, you would just keep on adding $50 to the previous amount. What do you think? Is this going to be linear? You guessed it. Yes, it is. Okay. Because you're going up by 1 here, you're going up by 50 here. And here we have to interpret the question for us to get this, right? If I give you a table of values, you just need to check. But right, let's go 125 minus 75, that's 50, right? 175 minus 125, that's 50. This minus that is 50, so it's consistent, right? Constant change in both columns, therefore linear relation. The rate of change, let's just try something here, okay? You pick any value here, right? So let's say 3, 225 and 0, 75. Like you pick any one of them. If you were to subtract the y values and subtract the x values, you all should get the same rate of change, okay? So we're going to use, or I pick, let's say that, that's better. I'm going to pick 3, 225 and 0, 75. And just picture this. Which one is further out as time goes by? Well, this one is to the right, and this one is obviously further to the left of the graph if you look at the whole thing. So it'd be 225 minus 75, and down here it would be 3 minus 0. So that would be 150. What is that? We're talking dollars, right? Over 3. The rate of change is $50, sorry, dollars and hours, right? The 3 goes in here 50 times, goes in there 1 time, so it's $50 an hour. So whenever you are doing the math here, make sure you have units, right? And you reduce it. So yeah, you guessed it, the rate of change is what this person is charging per hour, okay? So that's what that is. Could we come up with an equation for this particular scenario? And I know some of you, if not all, have done this in grade 9. By the way, try picking any other 2 points. So let's pick this one and that one, right? If we pick these 2 points, would you get the same answer, right? And the answer is yes. Okay. So let's box this off here. Equation. An equation for this linear relation? What would it be? Well, the answer is, first of all, you got to give it variables, okay? Let's give this T for time, C for cost. What would be the total cost to you, the customer? Well, the cost would be, we would charge $75 to start off, right? So I'm going to use this one here, my nice pen given to me, given to me by my son, plus 75 plus $50 for every hour. So we're going to call that T, right? And so this is the any possible equation, and this is the dependent variable. I just want you to already start thinking of this, right? This is the initial amount that you will be charged. This is the rate of change. And this here is the independent variable. So overall, okay, overall, I mean, this is how you come up with the equation. Your dependent variable is on the left. It's like your y, it's whatever. And your independent is on the right. And then the rate of change is attached to your independent variable. And the initial amount is just, it's your constant. It could be behind it, it could be in front of it, it doesn't matter. Okay. And just a reminder, how would you write this in function notation? Function notation. All you would have to do is C of t, right? Insert a bracket there, and then copy the rest down, and you have it in function, right? This is the equation, and function notation is just a little different. All right. Okay, this concludes 2.7. Let me just get you the homework. And there's your homework. So press pause, write it down. We're running out of time. Make sure you give this a try. And 5.7 is coming up soon. I will try to make a little AC again for these videos. That way you know I can get you feedback right away. All right, take care.